Hi everyone. Today let's look at the LeetCode problem 15 3 sum. Given an integer array nums, return all the triplets nums I, nums j, nums k such that I not equal to j, I not equal to k and j not equal to k. So basically we should find three different elements, the sum of which is equal to 0. Notice that the solution set must not contain duplicate triplets. Before you do this problem, I will highly recommend you to look at the 2sum and the 2sum sorted 2sum with sorted array. Especially the 2sum with sorted array. That is going to be we are actually going to use that solve this problem. Okay. Now let's take an example and see how to solve this problem. So one critical thing here is you are expected to have duplicates here. You can have, for example, you're able to see here, right? You have -1 and -1. So, and when you have the solution, you should ensure that you will not get duplicate triplets here. So I'll tell you the reason here. If you see here, I could actually have an answer where -1, 0, 1. Okay, these three can give me 0. Similarly, this 1, 0, -1 can also give me the same answer. But you should have only one of those triplets there. I hope this idea is clear. But if you want to solve this in a brute force approach, it will be an n-cube solution. The reason is that what you will have to do is first you will have to take -1. Fix this one and then find two elements within this all the possible two elements which will actually give you a total of 0. Similarly, like that you will have to iterate through each of the array, so array elements. So if you see here, first -1, then you go through this, so that finding that two elements is going to be like an order of n squared solution. So altogether it will be n into n square, which is n cube. So now let's see if there is a better way to do this and how the solution to the 2sum problem will help you here. Given the above example, the first thing that we will do is to make this solution much easier, we will sort this array. So you will end up with this as the sorted array. Okay. Now once you have this sorted array, what we can do is if we fix this as I, okay, then we have to find so this is sorted, so we have to find j and k such that they are equal to +4. And here you can use the 2sum problem on a sorted array to do this. So if you take this one, for example, what we'll do is we will first find the sum of these two elements. So that is going to be that is going to be 1, and then since it is less than 4, okay, we will move the j, and similarly we will try to find the normal 2sum sorted array approach to find the j and k. Now the tricky part here is, so if you see here, actually -4 you will not get a equivalent j and k. Now, when we come to -1, if you see here, what this will happen is we will take j here and we'll take k here. Okay, nums of I is -1. So now the target will become +1. Okay, so we have to find j and k such that the target sum is +1. So what we can do is here, if you see, -1 +2. So that is a valid use case. Now we cannot just stop there because there could be other elements also which would give you the same data. Okay. Now what will we do is we'll move j and we'll again check whether there is another possibility. 0 and 1. 0, 2. So if you see here, 0 and 2, sum will be 2. So that is greater than 1. So we'll move that is greater than 2. So being greater, we will move the right pointer, which is k. Now if you see, 0 plus 1 is basically 1. So this is also another case. So we will get 1, 0, 1. Now, so we have checked for this I. Now the problem is if I just move my I here and again repeat this, then if you see, we will get the same data -1, 0, 1 once more. To avoid this, what we do is, when we move the I, if we see a previous number which is equal to the current I, then we will just move our I pointer and move to the next location. This is to avoid duplicates. Okay, it will be more clear when we go through the code. Now, even in this solution, whatever I have so far told, there is one corner case. Let's take something like, for example, an example where there are 4 zeros. Now, what will happen here is, if you see, assume I is here. Nums of I is equal to 0. So we have to find nums of j plus nums of k, which is again equal to 0. And we go to the two-sum problem, two-sum sorted array problem. Okay. Now, if you see here, this 0 and this 0 sum will also give you 0. So that means you will have first this one. Now what will happen is, in the above approach, now if I just move the j pointer and then keep the k there, this also again gives you the same data. This is not valid. So you can see, right, you are finding duplicates here. To avoid this, what we will have to do is, even for j, similar to how we did for I, where if there are, we check whether the I minus 1 are duplicates, we will have to do the same thing and move the j until we find a case where j is not equal to j minus 1. In this case, you will not hit any of these. With this solution, we can code this up, so it will be more clear when I do the coding for this. The time complexity is order of n squared, because you can see, right, we have to fix one element and then do a two-sum operation here. So the two-sum operation is order of n, and then fixing and moving these elements, we will have to do it up to n minus 3. So that means it is n minus 3 into roughly order of n. So that is n square. And space complexity is going to be order of 1. Okay. Now let's take this case. So we will first do sort. Then what we can do is, we will just iterate through for auto I is equal to 0, I less than nums dot size plus I. First thing we'll do is, as I had mentioned earlier, we have to avoid, we have to check whether there are duplicates for I. So what we'll do is, I not equal to 0. So in the first case, you don't have to worry about it. And I less than nums dot size and nums of I equal to nums of I minus 1. We'll just keep incrementing I. And if nums of if I greater than nums of I, nums of size minus 3, then we can just break. Why I'm breaking here is, you could actually combine this in this condition, but yeah, it's up to you. So here, this is to check duplicates. Then what we can do is, our target is nothing but -1 into nums of I. J is equal to I plus 1 and int k is equal to nums dot size minus 1. Okay, so this is basically our, I can just put this as two-sum problem. Two-sum on sorted array. I could put it like a variant actually, which takes care of duplicates. While j less than k, nums of j plus nums of k greater than target, then we will just decrement k minus k. Else, if nums of j plus nums of k, we could do one thing, we can just put in this number is equal to nums of j plus nums of k to be j plus plus. Else, what we'll have to do is we'll push it into output array of arrays. So yeah. And then we can just tell out dot push back nums of I comma nums of k. Put it this way, j. And then we will increment L, because we also, there could be another L plus j plus k which would meet the same condition, so we have to check that. There we will have to do a similar case of what we did for I, because we wanted to avoid duplicates even in that case. So we will put it as not L, my bad, this was j plus plus, while j less than nums dot size, we can also make it as, I would put it as less than k, because you don't want to cross over, right? And nums of j equal to nums of j minus 1 j plus plus. So this will avoid duplicates here. This will be main target. Oops. Oops. Okay. All right, that looks good. Thanks. Have a good one.